in terms of approach as well. Although I have the feeling that econometric theory is a module together with micro, in which probably seen similar approaches to the subject. Yeah. I don't know whether all of you have done econometric theory, because I know it's optional now. You probably have. Econometric theory?
No, I did analysis.
Sorry?
I did analysis in second year.
Econometric analysis?
Yeah.
That. Okay, the key point here is, hopefully you're finding, is how's the material going? Sort of like it? Interesting? Not interesting. And as you get used to it in some ways, and you'll find the problems that's to be extremely frustrating, but that's the idea. Points to try. Make mistakes, that's fine. You have to make mistakes. If you know it, you won't be here. Right? So, and together with what's been taught in class, it'll all fit together in terms of showing you how to approach these from doing correctly. Ask questions at any time. Okay, so I'm going to start. So what we've seen so far, in terms of what we started doing last week. First, if you want to look at models in which there is a role for fiat money, and money is rationally valued, then you cannot do that within a framework in which there is a finite end to the economy. If the economy stops at some point, then essentially the problem is there is money left over in the last period, the money market has to clear, so someone has to hold it at date capital T, and why would they if they cannot use it in the following period? Because there is no following period. Unless it's all taxed away, but we don't have taxes in the model so far, so that's not going to be, it might be a realistic way of looking at things, but in terms of the theoretical question, that's not the answer. Okay, so that's the first thing that we saw. Second, I said, all right, now let's suppose that we're looking at a model in which there is a role for money because there are no loan markets, and you don't require people to have correct expectations. So you're allowing, in part, for expectations to be incorrect, and you relax the description of markets in the sense that what people do is based on today's prices, they form expectations about tomorrow's prices. It seems to be a very reasonable thing to do. And at the same time, they, based on those expected prices, they form demands for both today and tomorrow. But the only markets that clear are today's markets. So prices today are cleared by the auctioneer changing the prices that the auctioneer calls, which will of course affect expectations for prices tomorrow as well, and thereby affect demand for both today and tomorrow. But it's only today's markets that are required to clear. That was Hicks's idea of temporary equilibrium. As I said last week, it's a very nice equilibrium concept, but it gives too much flexibility. That's the problem. Okay? But what we saw there, and this was the important bit, and this bit it was not due to Hicks. This bit was done by a gentleman called Jean-Michel Grammont in his doctoral thesis in the late 60s. Okay? When he, in trying to provide foundations for monetary theory, he realized that in that very simple model, it could be the case that expectations respond too much to current prices. Because of which, you would specify the economy in such a manner, and I did that on the board. If something is not clear on that, you need to ask me. Because other than repeating the whole thing, there's very little else that I do. So there's something specific that when you read, you can't remember, or there's the figure that I drew, since it's not in the handout, if you are unable to construct it or you miss a little bit on it, you should ask. There's so few people that we can even deal with it on Thursday. But I need to know what is it that you're stuck on, if at all. So, there are specifications of prices and expectation functions together with preferences with the property that regardless of what price is quoted, both agents in that economy wish to buy more of the good than their endowment. And that happens at every price. Similarly, you can construct an example where both agents wish to sell. Basically what is happening is that you are considering a two-period problem, but as the price today changes, your expectation changes by a little more. And therefore you will always continue to have an excess demand for both agents or an excess supply for both agents. That's what was happening. right? And therefore, even in a very, shall we say, hospitable environment, one that seems very reasonable, in which money should have value, you pay to have a monetary equilibrium. That's what Brown was saying. So there's a role of expectations. Now, why is this important? It's important because when you think about the ISLM framework, in some sense, the case, see, if you were to take out what was important in Keynes, right, the 2 or 3 things that were finally accepted as being really important in Keynes. One was Keynes's view that, of course, there could be price rigidity. But this was understood even before Keynes. That if you have prices that don't really adjust as quickly as microeconomists like to think, that will have consequences in terms of macro effects. Because this is one. Keynes approached that issue by talking about the consumption function, etc. So he spoke about situations in which essentially prices are given, demand is determined by income. But the other thing, so these are, we've already taken care of at least 2 aspects. The third issue that Keynes pointed out to was the liquidity trap. Keynes' view was that, look, you cannot necessarily fix the problem with monetary policy. You need fiscal policy. So why? Okay? So the traditional view was that traditional view in terms of what Keynes offered, together with his theory of liquidity preference, which was there in some very preliminary sense before him. Okay? The earlier theory of money was almost entirely based on the kind of theory that we are working with, which is more or less a quantitative theory idea of money. So if you change prices, and you keep the velocity of circulation, the number of times money rolls over in a given period, constant, then essentially prices will respond. This was going to be fair. Keynes came up with the idea that, look, you also hold money for other reasons. It was a very reasonable way of thinking about things, as money as an asset. There's a cost to holding money, there's risk, etc., whether it's money versus bonds. And with that, he said that, look, it's possible that the central bank is able to increase the money supply. However, doing so will not make the interest rate reduce. The interest rate need not drop. The standard effect of an expansionary monetary policy is that the interest rate drops, which reduces the cost of investment and thereby stimulates demand. This is the usual story, even in the Keynesian framework. But Keynes said it could be the case that interest rates will not respond in that manner because of what he called liquidity trap. Okay, so this was Keynes' special case in some sense, problematic case, the most problematic case, actually. Okay? Now, there was a colleague of Keynes at Cambridge, whose name you might have heard. His name was Pigou, Arthur Cecil Pigou, if I'm not mistaken. Pigou was more of a microeconomist than anything else. Pigou said, and he retracted later, because people by then were so much in favor of Keynes that they were not willing to listen to anybody else. But Pigou said, wait a minute, if you think about the way people usually think about these things, you are agreeing that by increasing the money supply, the central bank, or keep the money supply fixed, let's say. This is the other way of thinking about what Keynes was saying, keep the money supply fixed, but since prices will drop, although slowly, over time, the drop in the price level will increase the real money supply and therefore shift out the LM curve. This is another way of thinking about what Keynes was saying. You shift out the LM curve, however, since you're in the liquidity trap, that does not affect equilibrium output. Okay, this is basically what the liquidity trap is. I don't know if you've seen these figures in this form, the idea being that you have output, you have the interest rate, you have the LM curve. Let's put it the way it is with the liquidity trap. Okay? You have an expansion of either money supply or, in this case, a lower price level. Okay, so that's where the price is P, and P prime is less than P. However, if your economy is somewhere over there, nothing's going to happen to equilibrium output. Okay? So this is, I don't know whether you've seen non-linear LM curves, but it actually makes much more sense than the linear approximations that you see. The linear approximation is fine if you understand that it's a linear approximation. It's not otherwise. Right? So, Pigou said that, look, when prices drop, one of the other effects that you don't see here, because this is the pure quantity theory effect, Pigou said when prices drop people will actually be richer in real terms. Okay, their assets will allow them to purchase more, and therefore the IS will shift. This was the P effect. Because the IS curve will shift. And in fact, this is the way quantitative easing is understood by, if I'm not mistaken, Bernanke. I remember reading this somewhere. It made a lot of sense. This is basically what he was saying. This is the Pigou effect. But notice that the Pigou effect needs to be thought of more carefully. As I said, at the time, people say, yeah, but it doesn't really work. Okay, and then later there was a gentleman called Don Patinkin who came in and did a sort of very, for his time, a very clear analysis. It's a Chicago PhD, if I'm not mistaken, integrating monetary theory and value theory. And he tried to formalize all of this, but it had its problems. But the example that we saw last week, what it's saying is what you need to understand in terms of this framework. What it's saying is, look, be careful. What Pigou is saying is correct, provided people do not expect prices tomorrow to be even lower. Because then you will wait. Right? Your savings are worth more, but you still have the choice of consuming today or tomorrow. If you think that prices tomorrow will be even lower, depending on how you discount, you might actually decide to wait even more. Elasticity of expectations is the key point. By how much do your price expectations for tomorrow change when prices today change? And what we saw in that example was, if expectations are elastic, so your expectations respond sort of more than 1 for 1, then you have a problem. You have the same problem. Is it okay? Yeah?
In a situation like this, would it be apt for a government to signal that they think there'll be inflation even if there's deflation?
Well, see, exactly. I mean, this, you see, there's more or less a recent literature, and I don't know why it's so important, but yeah, all right, which actually says that the communication by the central bank is very important. Okay? Now you can frame that in all sorts of ways, but to me, the economics of that comes out when you think of it in these terms. Because otherwise, you're simply talking about I don't know, the way journalists discuss these things on television. There's no framework. You just don't know what you're talking about. You say, yes, why? Somebody told me that, and you believe it. What does it mean? This is like everybody talks about quantitative easing as the same thing as the central bank buying bonds. So why do you give it a new name? Why would you call it something different if for the last 75 years economists have called it open market operation? If it's the same thing, then you shouldn't give it a different name. The answer is it's not the same. The reason is you're allowing a wider range of assets. That's the first thing. Okay, the way the central banks operate. But yeah, is it okay? All well? So that's as much as we will be doing in terms of relating what we are doing to macro. But from time to time, I'll be reminding you that look, what all this actually feeds in and gives you a much stronger foundation for things you might have seen in question. Okay? And of course, there's very little in the notes on all of these things. These are not the sorts of questions I'm going to ask you in these. It's very clear. It's all there in the background for motivation. But what we are actually focusing on is doing things formally. Which is not to say that I cannot ask you anything on temporary equilibrium. I could ask you to solve a demand problem with temporary equilibrium. Because you know how to solve a demand problem. You need to understand that you can actually do it in that framework as well. Okay? All right. So we are going to see our first proper model of money today. And again, the name Rameau is proper. Together with Yunez. You will not find this, I don't think, not that I keep searching for these things through Google, but you're unlikely to find anything on these things on the net. These papers have almost been forgotten. They're not taught anywhere. And I think it's a shame. It's a shame because a lot of macroeconomics for the last 30, 40, 50 years has been done in the general equilibrium tradition, but using a representative agent story. Think of the whole thing as just one agent. Because once you have one agent, there's no trade. If you have production, you can still talk about a Robinson Crusoe economy. But in an exchange economy, which is one agent, you're not doing very much. It's almost directly Pareto optimal, say. So I'm not at all fond of those models. I don't teach those models. Okay. On the other hand, I think these are models where you can actually go somewhere and deal with them and understand important things about monetary economics. Okay. So these are from the mid-70s. I mentioned Jean-Michel Gramon's name. Jean-Michel Gramont is the past president of the Economic Society. He's very old now, but he's still around. And he and the next model that we will see, which is Newton Bewley, were actually classmates at Berkeley. Both of them worked with a gentleman called Gerard Debreu, and I can say this now. Gramont was an engineer by training in France, and then he did his PhD in economics, mathematical economics. Bewley, on the other hand, studied history, and then at Berkeley he got a PhD both in economics and in mathematics. Yeah. Pretty impressive chap. And you remember from our macro class, Bewley later gave up economic theory more or less in terms of his research, and he started going around trying to understand why prices and wages remain fixed. And his books are there. Very distinguished economist. So, what's the Gromov-Nunez model? It's a model in which there's fiat money and it's held for transactions purposes. You think of a reason for holding money. Okay, and you will see why. Because we will have an economy in which we will be looking at what happens in the long run. So consumption will not change over time, endowments will also not change over time. So there'll be very few reasons for holding money in such an economy, unless you do it in some realistic but a manner which is different from what we've seen so far. So there'll be a transactions constraint, and that constraint has a standard name and it's used very often in modern macro theory for many years. So it's nothing very different from that. Since we're going to look at models in which money is rationally valued, of course, the time horizon has to be infinite. Money will be held in an economy which will never stop, which makes our mathematics a little different in that we will have to blindly do things. We will be able to interpret things, but there will be a lot where we can't really do it intuitively. We just have to accept a few things. And our key focus will be on two issues once we've developed the model. We will not talk about when monetary equilibrium exists. That's the difficult part of these two papers, so I'm not going to get into that. Our focus will be on our monetary equilibrium going to give you Pareto optimality. And if not, what sort of policy do you need to fix the problem? Okay? And that will feed in to some stuff that Milton Friedman, said for many years. And it will also feed in to stuff that Frank Hahn, who's a very well-known British economist, had to say to criticize what Milton Friedman was saying. Right? So we'll see how all that fits in. Hopefully, without. Okay, so what's the model? Time will be discrete but goes on forever. So 0, 1, 2, etc. Two physical goods at each date, which we shall denote by L, 1 and 2. No production. We do not have production in any of our models so far, so no production. It's exchange economy. There is fiat money. Okay, so fiat money is present in the economy, and it's used to transfer income across periods of transactions, and we'll see that in a moment. Two consumers, A and B. Consumers, agents, whatever you want to call them. So I equals A and B. Who will maximize discounted utility? So sum t going from 0 to infinity. Right? If time ends, we know that we run into trouble. So there's no terminal period. Beta I t ui xit, and beta is between 0 and 1. Okay? And the utility function is nice. Yeah.
So what does beta represent again?
Time discount. So the fact that consuming later makes you not as well off. You'd rather consume today than tomorrow, given everything else is the same. Roughly. So the utility function is nice, so it's strictly increasing and strictly concave. We're not writing, but that is assumed throughout. The endowments are strictly positive and the same at every date. Okay? So for both agents, the endowment is always strictly positive of both goods, and you have the same number of apples and bananas every period. Put that in words, currently, with inverted commas. Stationary. I will define stationarity of variables a little later, or other variables, but over here, just to note that it does not depend on time. You also have an initial endowment of money for each agent, which is MI from -1. Okay, that's the initial endowment of money. One other thing that I might as well put here. So the price of money is always 1. It was QM earlier, but now it's just 1. And therefore, PT is the price of goods in terms of money. So it's a two-dimensional vector, which we're going to take to be strictly positive. Now what I want to motivate is the form in which we set up the cash constraint. Cash in advance, it goes in all sorts of names. Okay, so I'm going to write my one-period budget constraint in different ways. Then we'll motivate this. So what is my one-period budget constraint? ET. Okay, I have two goods, so I need to be careful. So I'm going to write it as P. My two goods will be L and L prime. L, T, XI, LT plus P, L prime T, XI, L prime T plus MI T is less than or equal to PT, LT, omega I, L. Remember, omega does not depend on time, so I can drop the time subscript for omega. It does depend on who you are. That's PT, P, L prime T, omega I, L prime, plus MI, T minus 1. This is my spot market budget constraint. At date T. Is that okay? Since I have two goods, I've written it out as two goods. Something confusing you.
Sorry, just.
Yeah. Go on.
So you got PLT.
PLT XILT
Yeah.
plus PL prime T XIL prime T. They're two goods. M and then similarly on the right hand side. Is it okay? Yeah. Now, what I'm going to do is I'm going to write it in terms of net trades. So I'm going to write it in a few different ways. So first PLT and then XI LT minus omega IL, that's 1, plus P L prime T XI L prime T minus omega I L prime plus MI T, the amount of money that I demand at date T, has to be less than or equal to MI T minus 1. This is the way I will write my spot part interest rate. It's written exactly the same thing. No difference about it. Okay? Now, an equivalent way of writing this of course, is I can move one of these two to the right. Not saying a lot. Okay? So equivalently, I'm going to write it as, but I will write it out, although it's painful to do so on the board, but even so. Do it once, and we should be fine. Nothing's changed. I've moved one of these two terms to the right. Is it okay? Okay? Now, question? Okay. Now let's do the motivation. The point is that of the two goods, you're looking at a particular period, but we will look at a situation in which real variables don't change over time. Okay? So look at that particular period. You will either be buying or selling one of the goods and doing the opposite with the other. You'll either be buying tomatoes, selling bananas, or the other way around. Is that okay? Yeah? So, let L, this is just notation, but let L be the good bought by I, so L prime be the good sold by I. In other words, for agent I, we are saying this bit is positive and this bit is negative. Think of yourself. There are goods that you buy and other goods that you sell. Typically, you don't sell anything at your age unless you're selling something on eBay. Okay, but you might. Okay? So for any agent here, you would either be buying or selling two goods. Is it okay so far? Now, it is reasonable to say that when you buy, you're not going to get credit. The shopkeeper is going to ask you for payment. This is the other thing. But when you sell, it's quite likely they'll tell you, oh wait, it's only after we've received payment that we can pay you. Is that okay? So there is a delay in receipt of income. Make sense?
Why do you want to? Why do you want that?
I want that for the model to work. That's a simple answer. Okay? But I want it also because it seems to be a realistic description of how the world works.
Yeah.
I get paid at the end of the month,
You pay.
but I have my expenses throughout the month, so I need to make provisions for that. Same thing. Okay, over here we don't have labor. We don't have any labor of production, but the motivation is there.
That's just for the consumer.
There is more. There is more, but
Oh, yeah.
just to get that clear. Is that okay? The notation will be different. Hold on. We'll get there. Yeah, go on. Ask if you want to.
For the equivalency thing.
Yes.
Is there supposed to be an xi out of t in there? Because I don't see what they.
Oh, yes, you're right. Thank you. You see, the problem with this, thank you. Let me see if I can fit that in. Thank you. So this is xi L prime t p L prime t with a minus sign bracket. Thank you. Is it okay? Yeah? So now, Of course, since there's a minus sign, then with that minus sign, what we have here is going to be positive. So once I incorporate the minus sign, the whole thing actually is positive. Right? So this is how much I will earn as income when I sell. And I'm going to assume that I get only a fraction k of that. So k is some number which is going to be between 0 and 1. So we are going to operate assuming that k is strictly less than 1 and positive. Actually, it's greater than or equal to 0 is okay. It might be the case that I don't get any receipts until the next period. Yes?
Sorry, why are we assuming that if you're buying a mortgage, you're selling another? Because it could be the case that you're buying two goods.
Well, in equilibrium, and we will be looking at a stationary equilibrium, something which is constant over time. If you were buying both goods, how are you able to afford it?
With the endowment that you have for consumption.
Where with the endowment only of your initial money endowment,
Yeah.
because there is no other injection of money at all. So your initial money endowment with constant prices is unlikely to let you do that forever. That's right. Okay? Yeah. So there are some rough edges here, because if you want to do this carefully, it becomes much more messy and the maths becomes much more. Particularly when we come to the first order conditions. The first order conditions are not developed the way I'll be doing it here in ground units. Okay? Why? Because they were much more careful about how you can apply the Kuhn-Tucker theorem in this infinite horizon framework. It wasn't trivial at that stage. It's not. It's simply not. Is the motivation all right? Clear? Questions? Okay, so now we have, at each date, we will have a spot market budget constraint. We will also have a cash in advance constraint, or transactions constraint. Are we all right? Can you proceed? Yeah? So I'm going to erase a whole bunch of stuff and write down the optimization problem. We are not going to solve the optimization problem in class. You have to work out the first order conditions because there is this bit makes it a bit complicated. So you need to think about that and work it out on your own. And then of course I'll show you how to do it today. Because it's just a slight trick. But you should be fine with it. It's only when you think about it that you will understand it when I do it on the board. So, what's my optimization problem here? The problem is to maximize, I'm not writing out, well, I have it here, I'm going to write it up, xi0, which is a 2 vector, i0, xi1, mi1, etc. The sum, t going from 0 to infinity, beta it, ui, xit, subject to my spot market budget constraint, which I'm going to write in that form, but in vector notation. So, Pt xit plus mit less than or equal to Pt omega it plus mi e minus 1.
Sorry,
Yeah?
which add are we maximizing with respect to
Both?
Right.
The two goods?
Yeah.
Yeah. So these are vectors. That's why I said
Alright, sorry.
it's a 2 vector and m is just a number at each date. Right? So that's my spot market budget constraint at each date. There will be more things that I need to put in, and I will in a moment. And then, well, to begin with, I don't know which good I'm buying and which I'm selling. Right? So over here I specified which one I was buying and which one I was selling, and that's why the notation makes perfect sense. So now I need to introduce some notation to figure that out. So let's put the constraint in first and then explain the notation, and there will be an exercise on the problem set to let you think about this a little more. So xit, which is a vector, minus omega I plus on top, and then less than or equal to k times et xit minus omega I minus plus mi t minus 1. There will be a multiplier, which I'm going to write now. I could have used more than one board, and I usually do that, but then it becomes more difficult to clean up, which is why you have the printouts with you, so that I don't necessarily do that. So here the multiplier will be pi it. So I have one of these constraints at each date, and I will explain that notation in just a moment. In addition, we have given your initial amount of money, which is greater than or equal to 0, and you also have the non-negativity constraints. So for both goods, xit is greater than or equal to 0, and the amount of money that you carry at each date is greater than or equal to 0. And all of this, I'm just writing it here, is true for all t 0, 1. Is that okay?
It's K again, sorry.
There is, yes, that's K.
Yeah.
And K was the fraction of your sales that you're able to use in the current period. It could be 0.
Okay.
Go on.
Oh, right, okay.
Yeah, but the problem is, I still need to show you how this new notation allows us to do exactly what we were able to explain so nicely over there. That's the one thing that we haven't done so far. Okay? So now what's that notation? So what I want to pick up here is basically the value of what I'm buying. That's what I want to pick up. And over here I want to pick up the value of what I'm selling. So how do I do that? So here's a very simple notation which is standard in maths actually, but not so much in economics. It's probably why Gramo Unez never became popular. People found that to be something that they were not familiar with. So x plus, I use x here as a general notation for a variable. I could have used something else, it's just that it's there in the notes, so I'm going to continue doing that. Okay, it's not my consumption vector, it's my trade vector. Is it okay? So the notation x stands for any vector, so it's going to be in each coordinate, it's the larger of 0 and the coordinate. Remember, we have two coordinates here. Now, the reason I continue to use this notation is because it's completely general. Everything that we do in Gramo Unez is actually not done for two goods. You cannot do it with one good. The model does not work there. But you can do it with any number of goods. And the notation that I'm setting up will actually allow you to do that if you wish to. You don't want to, or you shouldn't in some ways, but you can. Okay, so what do I do here? I take my net trade for each of the goods, and I take the value of the net trade if it's positive, or I put in 0. So the good that I'm selling will drop out of that product. Okay, the product has two terms in it. This is a vector, this is a dot product. It has two terms. One term, which is positive, is the one that I want to pick up. And the other one, I want to drop, and I can do that because I'm going to set that equal to 0 if it's negative. Okay, and similarly, x minus, there are two minus signs here, that's the only problem. So there's one minus sign here, and you're looking at the minimum, and therefore you'll pick up a second minus sign there. The minimum of 0 and x1, and the minimum between 0 and x2. So I take my vector and I split it into what's called the positive part and the negative part. In the positive part, I keep the elements that are positive, plug in zeros elsewhere. In the negative part, I keep the elements that are negative, put zeros elsewhere, and then put the sign. You get exactly what we have here. Is it okay? There is, as I said, after today's class, it would be a good idea for you to try and solve the first exercise in problem set 3. Because that will make you think about this bit. There's also problem set 1 and 2, but hopefully those you've already done a little bit of work on. 1 is very little work, 2 has some work. Question? Anything else that you want to ask? Hopefully now you see why I made you wrestle so much with the material in the first few lectures. Because all of a sudden you start seeing things which are very difficult. But you also want to be familiar with the fact that, well, you can do this. Yeah?
That pi IT.
Yes, that's the multiplier.
Are we doing anything with it?
We will, of course. It will be crucial. So lambda, you've seen before, that's a multiplier. Pi will be the multiplier on that constraint. And that will determine everything. As you will see a bit later. Okay, so I'm going to write the first order conditions now. Okay, assume, so that we don't have to include additional considerations, assume that we are considering, okay, assume xit, okay, so that's a 2 vector, is strictly positive. So that these constraints don't bind. The non-negativity constraint on the consumption of the 2 goods will not bind. So that we don't have to include those multipliers in terms of what we do. Okay. So we're looking at a single agent's problem for the moment. So, problem set 3, exercise 2. What are the first order necessary conditions that are maximizing? Running out of time. So anyway, first order necessary conditions are the following: marginal utility at date t, XL, a good L, L being either 1 or 2, is, well, first you get your standard bit PTL lambda IT. Okay, that's from the spot market budget constraint is the usual way you should get it. Right. For the exercise, you need to write out the optimization problem with the constraints in the manner in which I've shown you how to write them. The inequality being greater than or equal to 0. Right in that form. We saw that last week. You want to do that for this problem. Okay? So this is the effect of the first constraint. But you also have your cache constraint. So that cache constraint is going to have an effect on your first order conditions, and that effect is the following. In fact, this is the key point. It's K, P, D, L, Pi, IT, if you are selling the good. While it's going to be equal to P, D, L, lambda IT plus PTL IT, if instead you're buying the good. Which you should expect from the form of the constraint. Whether you pick up a K or not depends upon whether you're in that term or that one. Is it okay? Just make sure that you know how to write it out correctly. Alright? And then for money, you get minus lambda IT plus lambda I t plus 1 plus pi I t plus 1 less than or equal to 0 with equality if you carry a strictly positive amount of money. So this was all the motivation that we saw last week. So that's your Euler inequality. So what you trade off is the marginal loss by giving up a little bit of consumption to carry one extra unit of money from today to tomorrow. Your marginal benefit will be what it does to your spot market budget constraint and what it does to your cash constraint. You have to take that into account. So it's the sum of the two which will give you your benefit tomorrow. And again, it's less than or equal to 0 in general because you might have the inequality constraint. It depends on whether this constraint is holding money binds or not. Okay? If you are carrying a strictly positive amount of money, then you get an equality there because that corresponding multiplier will be 0. Making sense? Is it okay? Are you alright? Very good. Now we are going to look at, so I'm going to erase this stuff now, okay? Let me stop it a little bit, a few minutes. So no more explaining these constraints, etc. Now let's see if we have the time in terms of what's going to happen here. So stationary equilibrium. So what we want is real quantities to be constant. So your endowments are constant over time. Equilibrium will be such that the amount of the good, of each good that each person consumes is constant over time. Stationarity. But it's a monetary economy. So you want to allow the amount of money you carry and prices to actually change at a geometric rate so that real prices are constant. Relative prices will be constant. I should say real prices. Relative prices will be constant. Okay? So this is a special case of perfect foresight where so you have the other things in your notes. For both agents, their consumption and money holding will be given by some constant vector for x and some alpha t n star for money holdings. Is that okay? That's what a stationary equilibrium is. In terms of demands, and prices will similarly be geometrically discounted. P star is some given vector. In what we've done so far, the amount of money in the economy is constant. I haven't said anything about it. We want to start by looking at the case where the amount of money is constant, and therefore, one of the things that as soon as you talk about anything of this sort, the initial distribution of money has to be compatible with the equilibrium that you're looking at. Otherwise, things will not work. In the same way as we fixed the endowment to be constant in time, you have to start with an appropriate initial distribution of money, which we will. Okay, so the particular case is where alpha equals 1. So the equilibrium condition for the goods will be sum over the two agents xi star minus omega I is the zero vector, and the sum over two agents of the amount of money that they carry is equal to capital. Okay? So we are almost done. Now, since you are at a stationary equilibrium, your first order conditions actually become a bit more special. Okay? Since Pt equals P star xit equals x star. Now look at the first order condition at date t plus 1. Okay, so I get beta I times beta it partial ui xi star partial xl will be equal to from my first order condition here. I'm looking at any one of the goods, it doesn't really matter which one. Okay, write it and I'll tell you in a moment. P star L lambda I equals 1 plus pi I equals 1. Okay, this is if you're selling L, instead of buying L, which is why I don't have a K. Stop and move. Okay, so that's all right. But at date t, from what I have within the brackets, I will have something similar except at date t. So I get beta I P star L lambda I t plus pi I t. So these two will be equal because of two different things. One, I'm looking at a situation in which prices are constant, consumption is also constant, and I also have geometric discounting in my utility, which is why my first order condition takes a simple form. Please make sure that you understand this. Okay, we're almost done. I'm going to stop in a moment. So let's just write what we have here. What I wish to do is observe that from my first order condition that I have at the bottom there, I can rewrite that now because of what I have here. Okay, so my prices will cancel out. Lambda it plus 1 plus pi it plus 1 is exactly equal to beta I pi it plus pi it plus 1. So Euler inequality becomes so this one, right? It's minus lambda it plus, instead of these two summed at t plus 1, I can write what I have here.